Alright, Chapter 3, complete printed circuit board design using Orcad capture and layout. Post-processing and layer details. Once the board is laid out, the routing of the board must be post-processed. The information from the MAX file is separated specifically the data file, with the Gerber files used for the board manufactured to make different parts of your board. Most of the post-processed file corresponds to the layers that you work with in the layout environment, but some of the files don't. Table 3.3 shows the Gerber file will generate with the post-processor exam. From the documentation listed at the bottom, the files are listed in order you might see them if you were in the cost section of a board. Most board manufacturers allow you to specify the order and inner and plane layers when you order your board. Key to understand the connection between the file with the layout of the board, other file with the post-processor generates, understand the layout handled with the organized layer. There are 6 different types of layers that layout maintains. The routing plane documentation. Drill, jumper, pad, stack layers. See Chapter C for the layout user guide with the edit layer dialog box. There are 17 layer templates, 15 plus 2 spare for the based on 6 layer types, and the layer templates are also called layer libraries. And then let's continue reading, and then we might go over the Gerber documentation file generated with the post-process. Continue. Listen, library, layer lib, library name. Column with the table 3.3 technology strategy file with the provide specific characteristics regard general layer types. When you start with a new board, a default set of layers listed for the layer name column in table 3.3 automatically creates a base on these templates so that if the board layers inherit the properties from the layer templates, you can modify the board's layers, but original templates remain unaltered. For example, internal layers are based on the inner layer template with the automatic name with the incremental as inner 1, inner 2, etc. See Chapter C for the layout user guide. Each layer also has a nickname listed, like layer nickname, column for the table 3.3. That is an alias for the layer name, the IN2 for the second inner layer, or I12 for the 12th inner layer. Application will have the layout with the nicknames more than the show of the layers and the names themselves. If you look at the data folder for the layout directory structure, you will see the PPF file extension names based on the layer nicknames that are binary database file with the define of the layers template. You should not change the name of the nickname because the layout will now because layout will not know what it is since there is not a template for it. But however, it's okay to change the layer name and other layer properties to suit the specific needs of your board. And we'll look over the drawing. You have your ASTP. Top assembly screen, top silk screen, top solder paste, top solder mask, top copper and component layer, power general, ground, inner layer 1, 2, layer and name numbereth, inner layer copper layer number 12, bottom copper and or component layer, bottom solder mask, bottom solder paste, solid silk screen, bottom assembly drawing. Drill tape files describing the drill hole size, location same as RS2, same for RS274D and RS274X. Alright, the D layer name DRLDWG, it's a drawing file. FABDWG fabrication drawing notes, or documentation. They have spare 2, which is this process report, spare 2 German design, either Gerber, and we'll continue reading. Number of types file generated with the post-processor depends on how you set up the post-processor. It depends on the complexity of your board. Requirements with your board manufacturer. For example, the file is generated only for the layers were enabled with a different number of the types of the file was generated depending on the output format that you choose. The 2 most common types of output formats are the RS274D and RS274X, aka Exelon. The Exelon format is typically used, but a board manufacturer should tell you what to specify what they need for which format they prefer. The post-processor is set up from the post-processor settings spreadsheet under the options menu, which will look at the specific settings in Chapter 9 and 10 understanding documentation. Some of the terminology for the printed circuit board fabrication business is left over from early printed circuit board manufacturing days. Drill tapes of the captures are such terms nowadays. The drill tape is just an electronic file that describes the drill hole size, just as like the other type files described in detail with the description column table 3.3. However, the original drill tape was actually a roll of paper or mylar with the holes punched in it that describe the hole size location for early computer numerical control machines. But it is still called the drill tape. But today, here's another example of Chapter 1 of the current technology. Photo plotting and laser direct imaging were discussed. In contrast, the older technology uses a Zaclon flash lamp and a shutter to expose the pop sensitive films or glass plates. The shutter controlled the exposure of the aperture, controlled the size of the exposed area. Any shape or drawing could be made by having an aperture of the different sizes and shapes. Lights would be shown through a selected aperture, moved in from X or negative direction, but the film was moved the X or Y negative direction. Positive or negative direction. Opening, closing the shutter in one area with the makeup pad would call the flash, while holding shutter open and moving the light source on the film the X and Y directions to make a trace was called draw. Technology today is most advanced in the concept and the same. The same terminology is shown in Figure 315 show the post-processor report in which you can. Alright, 315 shows the post-processor report, in which you can see the draws in the flash. I also noticed that the decodes, a Gerber decode is just a chronological number that specifies the size, shape of the arbitrary or any given layer. Other tools used with the layout. You should now be familiar with the PCB, the design flow, and layout tool set. With the following chapters, we'll look at how to assign footprints to parts from the capture, how to make your own capture parts, how to make new footprints with the library manager and layout, and how to set up the layout environment with the route complex boards. After you've mastered those tasks, other tools such as Gerber tool and Spectra, there's an interact closely with the enhanced capabilities of the layout will be introduced. Chapter 4, Introduction to Industry Standards.